to come up with one question to ask the judges. The question cannot be about today's tournament or teams.
So just ask it. Yep. Do you guys like bananas?
Huh? Yes, would you like bananas?
Yes, we like bananas.
Cool.
How'd you guys come up with the question?
Well, one of our team members just randomly came up with random questions, so, and it was, we should ask them if they like burgers, but we're the gorilla bots, so we decided we would change that to, do you guys like bananas?
Nice.
Transition?
Yep.
All right.
Yep. All right, so you guys now have a minute to get your project set up.
When it's time. So we don't hold them with us. Hold them on us. Okay, buddy? Yeah, I'm good. You have a hat? Yes. Here's a bag.
Find the first now.
My name is Zoe, and we are the gorilla bots. This is Slava.
This is Katie.
This is Ethan.
This is Bo. This is Fox.
Sorry, let me translate. We're the gorilla bots from Tallahassee. Would you like a banana?
We took inspiration from the inspection drone mission that uses a drone to inspect bridges. We decided to use a drone to measure and remove greenhouse gases from the air above the buildings in our community. Especially, we are focusing on CO2 emissions, but our solution can be adapted to many other different pollutions.
This is a model of our drone. It will fly on areas with high levels of CO2 and measure and collect the CO2 that I will find.
Yay!
Our drone is equipped with a brand new technology invented by the Center for Negative Carbon Emissions at Arizona State University. It is a large flat sheet of resin, essentially a membrane that attracts CO2 molecules in the air. We call this membrane toast. The omnidirectional atmosphere saving technology. When our drone has collected the CO2 molecules, it will return to base and deposit the membrane into the toaster. Then it can pick up a new membrane, charge its battery, and start again.
The material is an ion exchange resin. It is positively charged and collects a CO2 molecule for each positive charge in the resin. This material is like an artificial tree, but is 1,000 times more efficient at removing CO2 from the environment.
To maximize our efficiency, we use an entire fleet of these drones that would
communicate with each other as a group and would swarm the area and find pockets of CO2 and remove them.
Allow us to introduce to you the name of our solution. We call it iced coffee. Innovative, cost-efficient drone, CO2 filtering for everyone's environment.
Our theme this year is City Shaping. We are looking at problems in our community. We found a chart that shows the residential and commercial buildings contribute greenhouse gas emissions. Shows these 3. And between those two categories and the road traffic between them, they represent almost 30% of total greenhouse gas emissions. Many people think that factories are what cause the most emissions, so they aren't even thinking about houses.
We told our plans to Thrivent Financial, and they gave us a grant to purchase a small drone and a CO2 sensor. With this sensor mounted to the drone, we can measure parts per million of CO2 in the atmosphere.
Here's the drone and the CO2 sensor. I named this drone Ice Cube, and this is the sensor, and this is a little Arduino that we connected to the sensor. And we have this little LCD screen. We haven't gotten this working correctly yet, but when we do, it will, if you breathe on it, the CO2 in your breath will increase the numbers on the LCD screen.
At its current stage, or when you're done?
Well, at its current stage, if you breathe it into it, the numbers will go up.
Residential buildings are one of the highest CO2 producing structures because there are so many homes compared to commercial buildings. Clearing the land of trees, construction of homes, and heating and cooling of the homes throughout their lives, and eventual demolition of the buildings all produce CO2. Our iced coffee drone, combined with the toast membranes, is just one method we can use to make these buildings better for the environment and improve our neighborhoods. Do you have any questions?
How did your team decide on the, this problem to study?
So we realized that there was, because of, I'm gonna sound really dumb here, but
Nothing's dumb.
because of, I guess you could say climate change, and because of the greenhouse gases, and then we saw the drone, and we were like, what if the drone on the table, we were like, what if we combined the two and found a way to use the drone to fix all the carbon dioxide in the air?
So we decided we would do that, and we just kept building on our plan until
It evolved into this.
and
All right, you guys can transition
Well,
to.
1 2 minutes.
I'm sorry.
You guys talked about our Arizona State. Was there any professionals that you talked with?
we have not talked with them yet, but there is, we were looking, for, like a source to, get information from and put it into a presentation. And we came across this man named Klaus Lackner. So he basically does what we're trying to do. He's trying to extract CO2 from the air and either recycle it or put it somewhere and keep it there. And so.
He is where we got the membrane that the drone will fly around with to collect CO2. Yeah.
Okay. Have you shared this with anybody?
Well, I did share it with my mom. She is a biomechanical engineer, so she deals with day out basically. That's kind of all I can say since
It's complicated stuff. And we have shared with people from other teams.
You guys have any questions?
what did your mom think about the project? Did she give you any suggestions?
Well, she did give me one suggestion that we should find a way to turn the actual CO2 into energy for the drone. So like we use the energy for the actual drone itself, so it can stay in the air longer.
Is that something you guys are looking at pursuing, or as a
Perhaps,
possible
yeah.
question?
Yes.
So do you guys have any concepts or ideas of how that might work, or did she suggest anything?
No, not really.
Yeah.
Yeah.
Work in
Okay.
progress.
Not yet,
Okay,
not yet.
that's fine.
Alright. That's cool. So you guys can transition now into your robot design.
We don't wanna correct the wrong
I got one more. Got rejected by the drone.
Thank you.
What do you think of that new Spider-Man? With all the drones and
That was.
We have talked about that.
like drone holders.
Yeah,
Yeah,
there
yeah,
was
got
some
that right.
information.
And those all else that have also.
Okay. Oh, no.
It's not in here. I think you hid it somewhere. 'Cause- Okay, so do we start?
Okay, so this is our drone.
Robot.
Our robot, we have been the Gorilla Bots for 4 years, so we call it G-Bot Mark IV. And, as you can see, he has a very simple forklift to, well, anyway, it has a forklift in here, and there's, it can go left or right and up and down. And if you look at it, these holes right here come from,
Dude.
are for these attachments, and they can, these little pegs right here.
Bless you.
They can just drop in. And for the blocks, we can push them into the correct places. And the other missions, this one is for pushing, like, that attachment was for pushing 3 of the blocks. This is for pushing the rest of them. So we do all the blocks, 2 missions.
And for that mission, we have this jig that we line up on the wall, and it also has the pattern for what we put the blocks in.
And these are the sustainability upgrades.
Okay.
This is another one of our jigs. It the end broke.
It
Don't know
had
where it
ends.
is. But this goes in the black space in the table, and then this goes so it can line up 45 degrees because there's a stick coming out of it.
Yeah.
And this is our attachment for the traffic jam. So we put it on and it goes and lifts it up with the forklift.
Do you have any questions? Yeah, do you have any questions?
Which one's your favorite mission?
This one.
Yeah.
Yeah.
This one
The
gets
one
us,
that you did this.
yeah, this one gets us 150.
Yeah. Definitely that one.
How reliable are your missions? Like, how many times out of 10?
Well,
pretty decent.
This one, I would,
about-
I'd give it in the chance that it messes up a 9 out of 10. But the rest of them are more of a 50-50.
Okay.
Right.
Cause this one,
It's very reliable.
Yeah.
Yeah.
I mean, all it's doing is just pushing it one direction. So
pushing it and coming back.
it's all about lining it up correctly.
See how we line it up? Here's one. Is right here. This line, we line it up with the middle. If you picture the base, if you look at it,
Mhm.
there is the circle. And so we line this line up with the middle of the circle. And so when we press the button to like put it, let it go, it goes along, and if we line it up just right, it does it.
Okay, yep. Cool. Who does the programming? Just you?
All of us.
Well, yeah, we,
But-
few
So
of
for
us.
six-
We
Most-
transition out.
Yeah, we transition
Every
out
once in a while.
He
sometimes.
does most of it.
He
Everyone,
does,
everyone can modify the program if they need to?
Yes.
yes.
Okay, good. Wow, that's cool.
The same with running the table and setting up these ones.
Okay, cool. Do you have, terms escaping me, but do you have those sub blocks, what are they called?
The
Or
My
subroutines or my blocks?
My
Oh,
Oh, my
yes,
blocks.
Yeah,
yes,
my
yes, we do.
My blocks. We created a master program, and so you make all the programs that you have already and create a my block out of them and put them in the master program,
So,
and it goes on the screen.
master program, when you press the button on the master program, it just runs every mission, and all you have to do is you don't have to go around and like trying to find your mission. You can just press a button, the mission will do it, you set up for the next mission, press a button, the mission will do it, and you keep doing that until all the missions are finished.
It's an automatic transition.
Okay. Do you have the ability to repeat any of the missions
Yes.
if you chose to?
Yes.
Yeah?
There's lots of variables.
Cool. Cool. How'd you decide which missions to go after, which tasks?
Well, our coach, he plays, well, I don't know, do you still do that? Well, the beginning of the season, he would have the blocks placed out on the board and how much points for that game. And we figured that playing a whole bunch of them into a close thing, it was easier to do and it would get us a lot of points.
We also figured out that if you stack the blocks, it gets less points than if you actually spread the blocks out.
Okay.
So, the way we played the game was our coach would he would take blocks and he would put them out in different circles, and he would do the, innovative architecture. We made a little gorilla out of the white blocks. So, and so he would put that somewhere, and he would try and mess us up with like tilting the blocks and leaning them against each other. And we had to take our engineering notebooks and we had to look at the missions and try and tally them down and see who got the correct answer. And at the end, we would just go around and together we would do each one like crane, and then the other circles and more circles.
Well, that's all your time, so thank you.
Thank you.